Hello there, guys, and welcome to our first class for the first unit. This is a class that is part of Beehive School, and our subject is science. We are working on week number 1, and our grading section is 8 BYS. I'm sorry, so let's start. And here you have the topic and end in mind for today. So today's topic is lesson number 1, water and its properties. And the end in mind that we have is the following one. Break down the topic, water and its properties, into relevant content chunks to recreate some of its principles at a manageable scale at home. All right. So make sure to take a picture, a screenshot, or something from this section because you are going to use this information later on. So here you have a summary of the activities that you need to complete. First, you need to access the online platform. There you have the link. I will leave it in the description of the video as well. So you can access the online book and, of course, have access to all of the information we are going to study today. Then, please read pages from 4 to 13. And in this presentation, I'm going to give you a lot of information from the topic. But it is always necessary that you can go and read the pages so you can reinforce and expand a little bit more the topic. Once you are done, make a graphic organizer about the topic and share it verbally with the groups assigned by the teacher during the live session. Okay, so you have to complete these activities before the live session because while we have our live session, you are going to have a space for discussion and you're going to have a certain role as well. So it's very necessary that you have read and have your graphic organizer with you already. Here you have a small example of what a notebook format is going to look like. Make sure to include the dates in your notebook. Make sure to include the end in mind, the title, and of course the rest of the content. That in this case is going to be the graphic organizer. And those are the parts that I'm going to be checking later on in your notebook. So it's very necessary that you take them into account. Besides that, you have a small example of what your mind map is going to look like. So basically, you are going to have a central topic, and then several subtopics or information are going to be derived from the center. So, of course, this is very small in comparison to the one that you have to do, but it's just a general idea. Make sure to make it a little bit bigger and include more information about it. All right, so let's start with our topic. And first of all, we're going to start with the title, Water Down. What are some of water's roles on Earth? Which is something very interesting. Water shapes Earth's surface and weather, and it is vital for life. A human is over 70% water. And not only humans, but actually most likely all animals and plants depend on water in order to survive. Because most of their components in their bodies is water. And only 3% of Earth's water is drinkable. And of that, over 75% is frozen in the polar ice caps and not readily available for our use. So this is super important to take into consideration because imagine, out of all of the water that is found, only 3% of water is drinkable. And of course, we're having, well, it will be less than 1.5%. It will be around 1.25% of the water is available for human usage. So that's why we need to take care of the water resources that we have nowadays. It is therefore important to protect our water resources. What are some of water's roles on Earth? All weather is related to water. Water constantly moves from Earth's surface to the atmosphere and returns back to Earth's surface as rain, snow, hail, or sleet. Weather also depends on the amount of moisture in the air. So, basically, all of this can be summarized by the water cycle. So what happens in the water cycle is that, let's suppose that you have the ocean. In the ocean, a lot of water is evaporated, and then clouds are formed. Then after a while, because of the very cold temperatures that are found in the atmosphere, all of that water is going to come down again. So that's the way water is constantly flowing around our planet. And over time, water can completely reshape a landscape. Rain, rivers, and ocean waves slowly wear away rock and carry away sediment and soil. Glaciers scrape away rock and soil, depositing sediment elsewhere when the glaciers melt. So, as a summary again, let's suppose that you have a mountain. And the mountain is always exposed to rain, and of course, it's exposed to lightning and other weather conditions. So, that mountain over time can change due to this impact from rain, from water, and other natural phenomena. And of course, let's imagine that a very hard rain is going to impact the mountain. So a lot of rocks are going to be coming down the mountain, and then at some point they are going to come to the ground. They're going to be deposited one over another, and they are going to form new layers of ground. So that's another important role of water in building our landscapes and modify them little by little. And every living thing is largely made up of water, and nearly all biological processes use water. Water is needed for an organism's cellular chemistry and to regulate temperature and transport substances within the body. For humans, clear water is vital for survival and good health. Contaminated water sources are a major public health problem. One more time, we're going to recap on what I was telling you before. Water is extremely important for all living things because they are always made up of water. And besides that, we need to take into consideration that purified water is a vital necessity in all of our communities. But in Guatemala, unfortunately, there are parts in our country where people don't have access to purified water. And they have to drink water from rivers, from lakes that are very contaminated. So that's going to cause several health problems. That's why it's mentioned that that's one of the major public health problems, contaminated water in general. And now, identify at least 4 roles of water in this scene. All right, so what can you see right over here? Well, I can see many things. So first of all, I can notice that the roles that we have right here are, for example, the creation and modification of the weather in the clouds, the feeding of the plant. We can also notice that water is vital for a family that is trying to fish and, get some food in order to feed their family. And besides that, I can tell you that it is also feeding several animals that we can see right over here, such as these birds that are drinking or that are expecting some fish from covering. And it also has another function of exploration, such as the people that are conducting this boat there. And there are much more that we can see right there. But at least those are a couple of roles that we can see in water in the picture. Now, households' uses of water include drinking, bathing, flushing toilets, and washing clothes and dishes. So here you have a small graph that shows us the household's water used in the United States. So for toilets, 20% of the water is used, clothes and washing, 22%, shower, 17%, faucet, 16%, leaks, 13%, and other 5%. So something that hasn't been mentioned just yet is that huge amounts of water are used for irrigation. So let's suppose that you have a huge plantation of corn. So, of course, in order to grow that corn, you need to water the plants so they can grow, right? So, especially in the United States, the comparison between the amount of water that is used by humans, let's say, in their daily lives, just like the uses that are found in this graph with toilets, clothes wearing, etc. Irrigation is going to be drastically higher than that. So it might be another thing that we need to consider to regulate a little bit more. But there are many things that come with it, Like if you reduce the amount of irrigation, then we're going to produce less food. So if we produce less food, then we have to find another alternatives, or we can produce more hunger. So there are many things to debate about, but we're going to expand it during our live session, okay? And now we continue. Industrial uses of fresh water include the manufacture of goods, cooling of power stations, extraction of minerals, and generation of energy. And especially the extraction of minerals is something that I don't particularly like. because a huge amounts of water are polluted with all of the chemicals that are used in order to extract the minerals. So they contaminate the environment, they contaminate the water, and they can even produce higher health issues in families that are close by to those mining sections. Water is also used for agriculture, particularly to irrigate crops and care for farm animals. This is what I was telling you about before, and might be something that we will need to, regulate in the future. And now we're going to talk about the molecular attraction. What is the structure of a water molecule? Matter is made up of tiny particles called atoms, which can join with other atoms to make molecules. A water molecule is made up of 2 hydrogen atoms and 1 oxygen atom, in other words, H2O. So atoms are super small particles, let's say, that are going to be structurizing everything that we see around. For example, I have my cell phone by hand, so my cell phone is made of atoms. Also, we are made up of atoms. But specifically, when we talk about one particle that is going to, conform water, it's going to be H2O, 2 particles of hydrogen and 1 particle of oxygen. Each hydrogen atom is linked to the oxygen atom, forming a shape like a carved mouse's ears sticking out from his head. So basically you have, let's say, the oxygen particle in the middle, and then you have hydrogen and hydrogen from both sides. So that's a water particle. And what makes water a polar molecule? The water molecule has a partial positive charge around the hydrogen atoms and a partial negative charge at the oxygen atom. Anything that has a positive charge at one end and negative charge at another end is said to have polarity. A water molecule is polar. And in liquid water, the negative end of each water molecule is attracted to the positive end and another water molecule. So we have to remember some basic magnetism principles. So remember that opposites attract. So if we want 2 particles to assemble together, we need a positive and a negative charge. And due to the properties of water, in which at one end it's going to have a negative charge, and right at the other end it's going to have a positive charge, then it makes it a polar particle because it can assemble together with other particles of the same kind, let's say, due to the opposite charges that it's going to have, depending on the parts that you can see there. And what states of water occur on Earth? Most of Earth's water is in liquid form. Liquid water can change into an invisible gas called water vapor, or it can freeze into solid ice or snow. And at a very microscopic level, we're going to find that in the liquid, or let's start with the solid better. So the solid particles are going to look a little bit like this on the right. So you know that the water particles are all assembled together. They are pretty close to each other. And let's say that the particles are not moving that much. So when a solid substance increases in energy, or it increases its temperature, then molecules are going to start to separate a little bit. And the liquid state will look like this. Lastly, if we increase even more the temperature, it's going to be produced as a gas. And particles are going to be, everywhere around and way more separated. And what are some of the properties from water? So we're not going to have time to finish with the 4 properties of the water, but that's why you need to read the pages and, complement the video with your knowledge from there. So the property that holds molecules of a substance together is called cohesion. When water molecules stick together tightly because of their polarity, so water has high cohesion. Because of cohesion, water forms droplets and can fill a glass above the rim. Also, because of cohesion, some insects can walk on still water. So that's very interesting. So how much water is going to attract itself? How much water particles are going to attract other water particles? So we're going to stop right there with our class. Remember to read the last pages and find out more information about it. I'll see you during the live session, and goodbye, guys. Always take care.